Good morning, friends. Good morning, friends. This is Raj Mukherjee of Medical College Kolkata, first year MBBS student, and today's physiology video is about the gain of control system. So, I will proceed with that. The gain of control system is that the gain of control system or negative feedback system is calculated. The gain of a positive feedback system cannot be calculated because positive feedback system has no gain. So in this case we will consider the baroreceptor pressure control system, or we name it as system 1. So in the first case when the baroreceptor pressure control system of the person was functional, in that case what we had done one experiment that in the original case, suppose the mean arterial blood pressure was 100 millimeter Hg, 100 millimeter of mercury, 100 millimeter of mercury. So the original was 100, and after massive blood transfusion we had done one experiment. Now why are experiments performed? Now that is one part that has to be performed for the scientific reason. And after transfusion of large amount of blood, the mean arterial blood pressure increased to 125 millimeter Hg. Okay, so what is mean arterial blood pressure? What is mean arterial blood pressure? Mean arterial blood pressure equal to diastolic blood pressure plus 1/3 of systolic blood pressure minus diastolic blood pressure. Okay, now I will tell you later about the diastolic blood pressure and systolic blood pressure. For the time being, remember the formula. Okay, not just like this. Okay, so I will proceed. But suppose the patient had a car accident. Suppose the patient has a shock, had some disease. Okay, in that case the normal blood pressure was 100 millimeter Hg, but the baroreceptor pressure control system was lost. The pressure that system became defective, and in that case after massive blood transfusion, suppose the patient needed blood transfusion and we had to do blood transfusion. So after massive blood transfusion, the mean arterial blood pressure became 175 millimeter Hg. So how to calculate the gain? Gain equal to correction by error. Correction equal to the rise of the blood pressure when the control system is we calculate the functional case minus non-functional case. In the functional case we see that the rise in the after massive blood transfusion, the mean arterial blood pressure is 125 millimeter Hg, and when the system is non-functional, how do we calculate gain? We calculate gain by the formula that gain equal to correction by error. Okay, so rise of blood pressure, when we calculate correction by rise of blood pressure when the control system is functional minus non-functional. We calculate the functional case, when rise of blood pressure when the control system is functional, minus the case where the system is non-functional. Now 125. Okay, 125 is the 125 is the mean arterial blood pressure when the system was functional, means from 100 it raised to 125, and we subtract the rise of BP when the control system was non-functional, means we minus 175. So we get 125 minus 175, we get minus 50. So hold up to that. Now we have to calculate the error. The error is calculated by rise of the blood pressure in corrected state. Now normally is 100. So in the normal case, in the functional case, what is the rise after massive blood transfusion? What is the rise in the mean arterial blood pressure after massive blood transfusion? It is 125. So what is the rise? Original was 100. The after massive blood transfusion, the pressure was 125. So rise is 125 minus 100, so it is 25. So minus 50 by 25, it comes minus 2. Okay, now the gain of the system controlling the internal, we have one thing, the gain of the system controlling internal body temperature when a person is exposed to moderately cold weather, it is minus 33. Suppose this is system 2 and the previous one was system 1, that is the baroreceptor pressure control system, it was system 1, and this system, that is the system controlling internal body temperature when a person is exposed to moderately cold weather. This system is, I am saying, suppose this is system 2. Suppose this is system 2. Okay. So we can clearly, so how to calculate the degree of effectiveness of, so another thing, that the gain is always negative. The gain of a system, the gain of a negative feedback control system is always negative, and gain is calculated only for the negative feedback control system. For degree of effectiveness of a control system, we calculate the modulus of the value. We calculate the modulus of negative value. So the modulus is, how do we calculate modulus? I will show you by this sign. So how to calculate modulus? Modulus is calculated by this formula, that if the x is greater than equal to 0, x or any value, alpha, beta, gamma, y, anything, if x is greater than equal to 0, then we simply write x. But if x is less than 0, then we write minus of x. So what will be the modulus of, suppose, what will be the modulus of 2? It will be simply 2, because 2 is greater than equal to 0, only x. If x is equal to 2, it is simply 2. If x equal to 2, if x equals to 2, the modulus of x is simply 2. But if x equal to, x equal to minus 2, suppose, then the modulus of x becomes, we have to write minus x, because x is less than, minus 2 is less than 0. So how do we write that? Minus of means minus of minus 2. So it again becomes 2. So modulus of both 2 and minus 2, it becomes 2. So modulus gives converts a negative value to positive value. So thank you. I think you have understood well. So if you like the thing, then please subscribe and like this video. If you dislike the thing, then please click the dislike button. Thank you.